Alright, so we are in the middle of rebuilding the frame on my dad's excavator with new ears because he broke them off. They had the bosses built in. So we are actually just about done right now, and we're almost ready to put the boom back on. But I would like to replace the bushings. They're not that bad. They still have a lot of the groove left, which means they're really not that worn. But this is the only time to do this, when this boom is off. Especially it being off. We could have done the work without taking off the boom. Could have left it in place, but it was easier. But I thought it was just more efficient to just take it off. We need to rebuild the cylinders anyways. So I figured, you know what, let's just replace those bushings, even though they probably don't need it. So I've taken off many bushings in the past, and I usually either sawzall them out, which takes absolutely forever because it's hardened steel. It's very hard. Or I'll torch them out, but then you have a chance of kind of ruining the bore. But most people just torch them out, and they nick the bore a little bit, and it's not really that big of a deal. But what I would like to do is build a machine dedicated to pulling bushings, pushing bushings, pulling pins, pushing pins, that sort of thing. So basically I have a cylinder with a hollow rod, and you can put a cup on here. On the other side you put a stepped plate that goes in there that will pull the bushing out. I use threaded rod to go through the hollow rod on the cylinder, put a washer and nut on this side, and then it pulls it out hydraulically. And to somebody who doesn't work on heavy equipment, you may not have any idea what I'm talking about, so it's probably easier for you to see rather than me explain, so let me show you. Yeah. Alright, so this is rated for 10,000 psi. So we got to make sure that the hose going to this is good for 10,000 psi. So I can't really make a hose. Hopefully the foot pump comes with a hose that will work. That should be 3/8 NPT. Let's see here. 10,000 psi. Oh, NPT 3/8. That could be good. Maybe I won't have to do anything. Oh, you know what? Maybe this will be easier than I thought. I do like the idea of a quick connect. I think we'll put that right on the cylinder. We'll attach that to the cylinder. This end, it already came with a hose, which I'm really glad because this hose is rated for 10,000 psi. Yep. 10,150 psi. Great, that's awesome. So I don't have to get anything for this, which saves me a half a day worth of driving. So, yeah, put that right on there. Boy, I sure like telling you guys about this stuff. So to give you an idea, this is a 30-ton cylinder, hollow rod. So that's 60,000 pounds of pressure that I can put, or tension. So this should be pre-filled with hydraulic fluid. So I really, literally just don't need anything. Just hook up some air to it. So all I gotta do is hook up a fitting right there. They give you this, but I don't know what that's for. I never used something like that before. All right. Look at that. That's it. Wow, it actually retracts pretty good. I don't know if there's like a spring in there. No, I don't think so. This does screw out, so you can kind of like get a little bit more out of it if you do it ahead of time. Alright, so the biggest, heaviest wall pipe I have is this, which I believe is 3 or 3.5 inches. It's like maybe 3/16 wall. Pretty heavy duty pipe, but the inside diameter is not big enough to accept the bushing that I'm going to be pulling out. This is the bushing right here. This is the new one that I'm going to be putting in. The outside diameter is 85 millimeters. The inside diameter is 70 millimeters. But you can see it's not going to go through this pipe. So if you still don't know what I'm talking about, just wait a little bit, you'll understand. Alright, so in my scrap pile, I just happen to have this piece of 1141. I have no idea about 1141. I've never even heard of it before, but I got this off of eBay for maybe like $20, maybe like $5 or $10 in shipping. So this is 4.5 inches in diameter, and you can see even if I put that in the center of it, there's still at least a 1/2 inch of wall, which I think is plenty thick enough to pull this out. So all we really got to do is just turn this down. Really don't even have to do anything to the outside, but you know, you can't put it in the lathe without just turning the outside too. Make it look nice. We're just going to bore out the center. So I think I'm going to keep these jaws reversed like this. Gonna have to put these in the second step there. But if I turn the jaws around, it's gonna be right at its limit. And I'm afraid that by doing that, these jaws could actually go flying out of here. This might be pretty crooked to start out here. It's better than I thought. This thing is so thick that it absorbed all the heat that I just put into it. It's like still cold. All right, so I think what I'm going to do now is I got this bore here, which is probably almost 1.75 inches, which is plenty for that rod to go through. The threaded rod is 1 inch. So I think what I'm going to do is leave like 1/4 inch of material on the back side at that thick. One reason is because I can't bore much more than about another 1/4 inch, maybe 3/8, without hitting my jaws. So then I got to reposition everything, and I'm sure I could find a position to do it without running into the jaws, and I could complete the job. But rather than do that, I figured let's just leave like, 1/4 inch, 5/16, 3/8 maybe on this side at that diameter. We'll bore out all this on this side all the way up to there. And so it'll be like a cup. It'll be like a cup with a hole in it. That will also give the whole thing a little bit more rigidity. I don't think it's really going to matter because it's against the solid flatness of the cylinder. But I know one thing, it's definitely not going to hurt anything, and it would allow me to continue without having to reset up. So I'm not being lazy. I just, first of all, in a 3-jaw chuck like this, if you reposition, you're going to be a little bit off. Second of all, like I said, it's not going to hurt to have that little bit. It just means that I can't use the full depth of this to press out the bushing. But once you get to the last 1/2 inch of the bushing, it doesn't really matter anymore anyways. You can just pop it out. So what I'm going to do is I'm going to use this stop right here. This stop you can set to wherever you want. So I'll set it to stop right there. So every time I make a pass in, it'll stop. I'll reset it and keep going. And once I got it bored all the way out to the outside, then I'll go back in. I'll bring it back to that stop, go just a little bit further, and then I'll just run it this way. And it will make that nice and smooth. So at first it might be a little bit rough, but at the end we'll smooth it out. So this stop, you move it over, you tighten that Allen screw, and then you can actually just fine tune it right down to the thousandths. So now I'm just going to chamfer everything over a little bit. as this cylinder is pulling the bushing out, this allows the bushing a place to be. So just imagine I still need to put a piece right here to pull this bushing out. But as I'm pulling it out, it goes into there. So the next thing we got to do is machine down a piece that's just slightly below this, which I think is 85 millimeter on the outside of the OD. We got to machine something that's just slightly below that. I'm thinking at least ½ inch wall, maybe even a little bit more. And then we're going to chop off the two sides of it so that you can slip it around sideways and get it into the bore. Again, let me just show you. I don't have much of a selection for what I'm about to do. This is the only piece that'll really work without starting out with a huge piece and taking off a massive amount of steel. This is 1050 steel. So this is going to be kind of a challenge for me because I got to part. Parting is where you basically like just cut it off. And that's something that I've been struggling with. I get some really bad chatter. So let's see if we can make it work. So my parting tool will only go 3/4 of the way. You know, I guess I didn't realize that I should have got another parting tool that was like a left-hand one. I think this is a right-hand, because the piece that I want is going to be on this side, so I want that to go the opposite way. We're going to have to get creative here. I do have this, and this should be deep enough. It's going to take off a lot of steel, but it should do the trick. The good news is this is a very stout insert. The whole tool and insert is very, very stout, so I may not get chattering, but it may take a while and I'm going to waste a lot of material. I just had an idea. What if I do this from the backside? Run it in reverse. That should work perfect. Now I do need to give it a little bit more relief right here. I might as well do that while I'm still on the front side here, because it does have a shoulder that needs to go in. Alright, so here's the piece, and you can see that I cut two sides off. That is to be able to slip it through the bushing, turn it back, and then pull it, because otherwise there's no way to get on the other side of the bushing to pull it. So at this point we're ready to pull at least one bushing. Of course it's going to get covered in grease. Just go ahead and put that right on the ground, right? Just put it on the ground right there. Yep, it's going. Let's tighten that up a little bit. So this excavator calls for 2 dust seals, one on the inside and one on the outside of the bushing. But for some reason there's not enough room for that, so somebody must have ground this down a lot, because we lost about 3/16 here. Or the excavator wore that face out. So it had the seal on the bottom, but not on the top, so we'll just put the seal back on the bottom. That way when you grease it, it doesn't push the grease down into this no man's land here. So for putting the new bushing in, what I can do is put this cylinder on top of the bushing here, put the rod through it, put a plate with a hole in it on the bottom. So then when the cylinder rod pushes up, it pulls on this plate that's here, which in turn pushes the whole cylinder down. And the bottom of this thing is very stout. You could definitely push something with that. I mean, I guess if you were really worried about it, you could put another plate like that on the bottom of that cylinder, but I'm not really worried about it. We'll keep an eye on it. The good thing is you can actually see what's going on versus having a cup here and the bushing is going through the cup and you can't see what's going on. Now we can see what's going on and inspect things as we're going. The only thing is we do need a longer rod now, because we need to go through the whole boom, which is almost 2 feet, plus the length of the bushing, plus the cylinder. So I had to get a 3-foot rod for this. So I had the bushing in the freezer for a few days because I thought I might just drop it in, but in order to do that, you should really heat up the bore, and with that dust seal being in there, I just didn't want to do that. So I chose the route of just utilizing this puller and pusher, and this will go in a little easier, but it's not necessary because we got 30 tons of force. Definitely got some frost on it. Just gonna get it going straight. Actually, it almost seems like it might go in. Alright, so we got both the telehandler and the crane on this, so let's just get this while it's in the air. It's a lot easier than laying it down again, because the next move is to put it on the excavator, so let's keep it upright. I know we're relying on hydraulics, but we're relying on double the hydraulics, so it should be okay. Both of these machines are capable of lifting this, so it shouldn't be a problem at all. Let's just quickly get this bushing out, pop the new one in. All right. So I'm going to release it. Tighten it up a little bit. Yeah, try to shift that over. There you go. Alright, go ahead.
I'm not going to be ready for it.
One very frozen bushing. So I'm working after hours right now, and I want to make like a little bit of an extension for that cup because it wasn't quite long enough. So I got this 1-inch piece of steel. This is just grade 50 structural. It's pretty mild. This is the piece that I cut out to put in the bosses on my dad's excavator. So it's just a scrap piece. Let's see if we can make something out of this really, really rugged piece here. Alright, so here's the extension I made. It gives a good 3/4 of an inch of extension, which is more than enough for what I need. So I did also give this more of a taper. It's a deeper taper. And that's because when I was pulling the second bushing out, it was hitting, and it was, you guys didn't see it because I just fast forwarded through that, but basically it was just hitting by a little bit and it wasn't allowing the bushing to come out. So if I had this deeper taper here, it would have easily gone through, would have just slid to the side and then it would have gone through. So I got that taper, but on this I have an even deeper taper. This is like way in. I tapered the whole thing, the whole 3/4 of an inch. So also I made a shoulder here so that when you put this on there, it gives it a solid stop. There's almost no play in there whatsoever. So with the two of these together, I got everything I need for every machine that I have, except for maybe my mini excavator. I might have to make something small. But all my other machines, this will work. I suppose if I get another bigger machine like the 240 that I had, I could make something else, but this will work for everything else that I have. So one thing I didn't really realize in this whole process was that you just get everything extremely greasy when you're doing this kind of stuff. So ideally, cleaning all that grease out would be great, but there was a giant cavity with tubes of grease in there, and it just wasn't going to happen. It would take half a day to clean that stuff out. You guys saw nothing. But yeah, turning this out of that scrap piece of steel was pretty interesting. Always wanted to do that. Took a little bit of back and forth kind of stuff, but worked pretty good. Also, when I was making this piece right here, I had to part that. And my parting tools, you saw the struggle that I had. But I got some new stuff. So I got this parting tool that goes into here. So now I got like, I mean, you could probably get like 3 inches of parting, but you probably wouldn't want to be out on the end there. You'd get a lot of chattering, I'm assuming. But I did use that already, and I got like 1.5 inches deep. So that worked pretty good. I also got another one, which is high-speed steel. So this one also goes very long, depending on how much chatter you can deal with. I haven't used this one yet, but you can grind it back into shape if you get it dull or you break it. The other one takes inserts. Luckily, it takes the inserts from my other parting tool. So now I have 1, 2, 3, 4 parting tools. So hopefully that should help in the future, because parting was definitely something that I was not having good luck with, but I did part with this, and it took a while, but I got it successfully. And right at the end, when it was about to break off, I broke the insert, but I was still very satisfied with that. Also, one thing to note, you can't really just go to the store and buy threaded rod and expect it to hold up. A lot of that stuff is like grade 5 or even weaker, and that stuff really won't hold up. Even a 1-inch grade 5 rod won't hold up to the 30 tons that cylinder has. So this is grade 8, and this is coarse thread. That's the 3-footer. That's what I could find locally. This was the 2-footer. That's fine thread, and I think that's actually grade 9. So that's got like, I can't remember, but like it's like 120,000 pounds of tensile strength. Or maybe it's even more than that, honestly. It could be more than that. But yeah, if you want 60,000 pounds worth of pulling force, you definitely need an upgraded threaded rod. You can't use the stuff from Lowe's or Home Depot or something. Not if you want the full 30-ton capacity. But I got to get these cleaned off. That's why they're over here. I got a bin of diesel over there. I'm going to clean them all off. Anyways, that's it for this video, guys, and I will catch you in the next one.